GR IAS Academy.
Hello everyone, I am Ananta Krishna from GR IAS Academy. In this series, we are going to discuss about UPSC Mathematics optional PYQs. So let's start. So the first question is, a rectangular sheet of metal of length 6 meters and width 2 meters is given. From each of the four corners, equal squares are removed. Okay. Then the sides are then folded up to form an open rectangular box. So what we need to find approximately the height of the box such that the volume of the box is maximum. Okay, let's go. Right. So what is given first? A rectangular sheet of length 6 meters and width 2 meters. So a rectangular sheet is given. Here the length is 6 meters and the width is 2 meters. So from this, what is given? From each of the four corners, equal squares are removed. So we don't know the side of this. We don't know the side of the square yet. So let's call it x. That as x. So from each corner, one square is removed. That is of size x. Okay. So again, let's draw here another. So we get x. So we have four corners. From four corners, four squares are removed, each with the sides of x. So what will be this length? Since 2x, this is also x and this is also x, right? Because it's a square, all sides are equal. So this will x plus 6 plus, there are 2 x's. So 6 minus 2x, right? Simply. So this will become 2 minus 2x. The width is 2 minus 2x because the four squares are removed. Then what is given? The sides are then folded up to form an open box. So since these squares are removed, the remaining sides, we can call them flaps, are folded up. So from this side it is folded up, and here also it is folded up. From this side it is also folded up, and this side also it is folded up, such that it becomes a box with the base as this area. And what is given? No top. So there's no top. What will be the height of this box? It will be x. It will be x. Since we are folding this side will become vertical. So the height will be x. So what we got? The box length as 6 minus 2x. Width as 2 minus 2x. About height as x. Okay. What we need to find now? Find approximately the height of the box such that the volume of the box is maximum. So what is the box shape? The box shape is cuboid. So what is the volume of cuboid? It is length into width into height. So volume is length into breadth or width into height. That is, let's call it V of x because we are using the x as a variable. Length is 6 minus 2x. Width is 2 minus 2x. And height is x. So let's calculate this. Let's simplify it. So first let's calculate these two brackets. 6 into 2, 12. Minus 6 into minus 12x. Minus 4x. Minus 2x into 2x plus 4x square. Minus into minus is plus. Into x. Do not forget this in each of statement. It is important. So let's calculate this. 4x square minus 12x minus 4x becomes minus 16x plus 12 into x. So it is V of x is 4x cube minus 16x square plus 12x. We got the volume of the box. Now what we need to find? We need to find approximately the height of the box. Height of the box is x. Such that the volume of the box is maximum. So we have a function and we need to find its maximum value. How can we find that? First we need to find the critical points of this with this function. So to find the critical point we need to derive it. So we need to find v dash of x, or you can say dv of x by dx. Okay, so let's find the first derivative. So we have v of x is equals to 4x cubed minus 16x square plus 12x. So 4x cubed minus 16x square plus 12x is the volume function. What we need to find now? V dash of x is equals to 4x cube is 3x square. 4x cube into 4 into 3 is 12. 12x square. Similarly, x square is difference, x square by dx is 2x. So 32x and 12 plus 12, because dx by dx is 1. So we got the first derivative of the volume function. Now to find the critical points, that is the curve is flat in the graph. For v dash x is for v of x is when v dash x, that is first derivative of the function, is equals to 0. So we need to find v dash of x equals to 0. We need to find the x values here. So let's put it in the equation. 12x square minus 32x plus 12 equals to 0. So let's remove the common factor. What do we get? Common factor is 4, right? So 3x square minus 8x plus 3 equals to 0. This is a quadratic equation we got from the first derivative. Why have we why are we calculating it equal to 0? Means we need function has its maximum or its minimum, that those are critical points when the first derivative is equals to 0. Okay, so that is the theorem. So we need to find x. Let's calculate x. 3x square minus 8x plus 3. So 3x square minus 8x plus 3 equals to 0. We have a quadratic equation in the form of ax square plus bx plus c equals to 0. So what is the formula? X is equals to, so I will write the formula here first. Ax square plus bx plus c equals to 0. If quadratic equation is in this form, then the formula will x is equals to minus b plus or minus the root of discriminant by 2a. So this is the formula for x if a quadratic equation is in the form of ax square plus bx plus c equals to 0. So let's apply that. What is b here? B is minus 8, not 8. B is minus 8. Always see the sign. It is minus 8. So minus of minus 8 plus or minus root of minus 8 square is, first let's write minus 8, negative 8 square minus 4 into a is 3, c is also 3 by 2 into a. 2 into a is 3. So let's calculate this. Negative into negative is positive. So 8 plus or minus square root of 8 square, negative 8 square is 64. 64 minus 4 into 3 into 3. 3 into 3 is 9, 4 into 9 is 36. So 36 by 6. So we have 8 plus or minus 64 minus 36 is 20. Right. Square root of 28 by 6. So 28 can be written as 4 into 7. So it will be square root of 4 is 2. So it can be written as 2 root 7. So 8 plus or minus 2 root 7 by 6. That is x is equals to 8 plus or minus 2 root 7 by 6. So we can calculate further here. Root 7 is approximately equals to 2.63. Okay. X is equals to 8 plus or minus 2 root 7, right? Root 7 is approximately equals to 2.63. 2 into 2.645. Let's go to, okay. So 3x square minus 8x plus 3 equals to 0. That is what we 3x square minus 8x plus 3 is equals to 0. So let's find out x. What is in this? What is the quadratic equation? Is in the format of ax square plus bx plus c equals to 0. So what is the formula? If a quadratic equation is in form of ax square plus bx plus c equals to 0, then x is equals to minus b plus or minus square root of the discriminant b square minus 4ac by 2a. Right? That is the formula. So in this equation, x is equals to minus b. What is the b? What is b? b is minus 8. So it will be minus of minus 8 plus of minus root of b square is negative 8 square minus 4 into a is 3, c is also 3. One second. C is also 3 by 2 into a is 3 again. So x is equals to negative into negative is positive. So 8 plus or minus square root of this is 64 minus 4 into 3 into 3, that is 4 into 9 36 by 2 into 3 is 6. So x is equals to 8 plus or minus root of 64 minus 36 is 28 by 6. We can write this 28 as 8 plus or minus square root of 4 into 7 by 6. Therefore x will become 8 plus or minus square root of 4 is 2. So it is 2 root 7 by 6. We have two values for x. Now let's calculate further and remove the third here. The approximate value of root 7 is 2.645. So let's keep that in place. 8 plus or minus 2 into 2.645 by 6. What will it become? X is equals to 8 plus or minus 2 into 2.645 is 5.29. Yeah, 5.29 by 6, approximate value. Okay. So x, in the question also they have asked approximately. So you can remove the third here. So let's calculate it. 13.29 by 6, or x is approximately equals to 8 minus 5.29, that is 2.71. 2.71 by 6. We have two values. So this is approximately equals to 6 4s are 24, so 0.4, and the 30 is 0.251, 0.45. 31 by 6 is approximately 5, right? 6 into 5 is 30. So x approximately is 0.45 in this one. What about here? 6 2s are 12, so 2 point and 1 2 again, so again 2, and there is 9, so 2.21 approximately, 2.215 exact here. X is 2.215 or x equals to 0.45. We have two values. So what are the values? X is equals to 2.215 or x equals to 0.45. So here what is x? X is a side of square. So x should always be greater than equals to 0. And what is the height, width of the, this is the width, right? Width of the box, that is should also be greater than 0 because it's a side. So by calculating things, 2 is greater than 2x. Dividing the equation by 2, we get 1 is greater than x. And from this both equations, we can say that x belongs to 0 and 1. 0 and 1. Therefore, x belongs to 0 or 1. So what is the only feasible solution from these two? From these two, this is not possible, right? 2.215 does not be in the valid range for the value of x. So x equals to 0.45, that is x equals to 0.45, that is all. What is x? Height is the only feasible solution for the volume of the function where the first derivative is equals to 0. So does this answer our question that we have found the height of the box such that the volume of the box is maximum at this height? we got the value, but this is a critical point. We don't know if it is maximum or minimum yet. To find out that, we need to find the second derivative. We need to find the second derivative of the volume function. If the second derivative is less than 0, then it is maximum. If v dash of x is greater than 0, then it is minimum, and if it is equals to 0, no, not a critical point, or you can write it as neither. You can write it as neither. It is a critical point, sorry, but it's not a maximum or minimum if it is equals to 0. So this is, with this we need to find if the point, that is x equals to 0.45, is maximum or not. So let's calculate v of x. So what is the first derivative? So let's calculate this. So what we got the first derivative as? We got the first derivative as 12x square minus 32x plus 12, right? So what is v dash of x? 12x square minus 32x plus 12. Let's differentiate it again to find the second derivative. X square is 2x, so 12 into 2 is 24x. 24x minus 32x, dx by dx is 1, so 32, and constant derivative of constant is 0. So we got the second derivative. Now let's substitute x equals to 0.45 and see if the second derivative is less than 0 or greater than 0. So 24 into 0.45. 24 into 0.45 is less than 32. Right, from here only we can say 24 is already less than 32, and 0.45 means 12, it less than 12. Then v dash of v double x is less than 0 for x equals to 0.45. We got this statement because 24 into 0.45 is less than 12 and 12 is less than 32. It will be the negative value. No need to calculate here completely. So what is the second derivative here? Less than 0. If it is less than 0, then it is the maximum. So x equals to 0.45 is maximum point, maximum critical point. This point is a critical, okay. So we got the answer. Find up what we need to find exactly. Find approximately the height of the box such that the volume of the box is maximum, where it is maximum at x equals to 0.55. So this is the answer final.